a chain surveying? Hmm? No one?
Area where cannot be measured directly, sir.
Area where cannot be measured directly. Any other?
With chain, linear measurements are taken. In
Hmm.
compass, angular measurements are taken.
Okay. Any other?
Sir, triangulation or traversing?
Okay, the principle of chain surveying is triangulation, whereas the principle of compass surveying is traversing. Okay. In simple, can we put it wherever it is not possible for doing a chain surveying, we can go for compass surveying? Do you all accept? Yes or no?
Yes, sir.
Yes,
Wherever
sir.
it is not possible for us to do chain surveying, we'll generally go for compass surveying and vice versa. So, what are the situations where you can't go for chain surveying? The disadvantage of chain surveying will be that by default the advantage of compass surveying. So, what are the areas where you can't do chain surveying?
Undulated areas, sir.
So, when there are many undulated areas and where it is not possible for you to take the linear measurements accurately, then we'll be going for the compass surveying, provided there is no effect of magnetic field in and around the area to be surveyed. Okay, so where you can't measure the linear measurements, for measuring the linear measurements accurately, you need to drag the chain or tape on the ground perfectly. If there are more number of undulations, either in the form of bushes or in the form of depressions or elevations, etc., you can't get the exact length with the help of a chain or a tape. So in those cases, what we'll do is we generally go with the help of a traversing technique by using compass instrument, and we'll be calculating the area indirectly. So we'll be measuring the linear measurements also in compass surveying, but the quantum of linear measurements will be less when compared to chain surveying. So with the combination of a linear measurement and angular measurement, we are going to determine what is the area of the enclosed surveyed area or survey field wherever you are doing your work. Okay, so that is the basic difference between your compass surveying and chain surveying. Okay, but we need to keep one point in mind. Whenever you are going for compass surveying, you need to ensure that there is no effect of magnetic field in that area in the form of electric poles, okay, or in the form of high tension wires, or in the form of any magnetic materials, magnetic ores or iron materials near the instrument, because the compass consists of a basic item in the compass is the magnet. So if at all there are any magnetic cores or smart watches or high tension wires, the magnetic needle in the compass is liable to deviate from its actual position. So you'll be getting a wrong value. Okay, and 1 degree wrong value is equivalent to 109 kilometers of linear length. So assume if you are doing, when you're reading an angle of 315 degrees instead of 315, if you read it as 316 degrees, instead of going from Hyderabad to Vijayawada, you'll go land in Guntur. Okay, that is the impact of 1 degree variation. So it will result in a value of 109 kilometers in comparison to linear lengths. So you need to be very careful whenever you are using a compass instrument, and you need to definitely ensure that there is no magnetic field in and around, okay, other than the compass. So is the screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. I'll just walk through this theory part for 5 to 10 minutes. Then I'll go into the concept of whole circle bearings. Okay. So chain surveying can be used when the area to be surveyed is comparatively small and is fairly flat. But when the area is large, undulated, and crowded with many details, triangulation is not possible. In such an area, the method of traversing is adopted. What do you mean by traversing? Triangulation is nothing but dividing the given area into a set of triangles, right? What do you mean by traversing?
Network of surveillance.
Network of?
Surveillance.
It's a network of survey lines, and you are going to move around the boundary of the area to be surveyed. You are not going to go into the middle of the area, but you are going to do the survey along the boundary. In the right figure, you can see there are two types of traverse. One is closed traverse, another is open traverse. These points are the survey stations where you are going to establish your instrument and you are going to take the readings of that. Okay, so from this first point to second point, you'll be determining what is the angle. Then you'll be determining what is the linear length using a chain or a tape. Then you'll shift the instrument from first point to second point. You'll set up your instrument at the second point. From second point, you'll be sighting the third point and you'll be determining what is the angle. Then again, using a chain or a tape, you'll be measuring the linear length. So like that, you'll be moving around the boundary to be surveyed. Once you get a figure like this, then you can determine what is the area of this by again dividing it into a set of triangles on the map or on the plan, or into a set of quadrilaterals, etc., or trapezoids. Okay, for which we have very simple equations. By using those equations, you can determine what is the area enclosed within this given boundary. So in a closed traverse, what do we mean by closed traverse? Is the starting point and ending point of the traverse lies at the same point. If I'm starting my survey at this point, I'm also going to end my survey at this point so that I'll get a closed boundary. The advantage of doing a closed traverse is you will know whether you have done the survey accurately or you have done some mistake. Okay, suppose you have done some mistake. Instead of this point closing at this point, the point may close at this position only. Okay, ఇక్కడ క్లోజ్ అవ్వాల్సిన పాయింట్ లాస్ట్ లైన్ షుడ్ ఎండ్ ఎట్ దిస్ పాయింట్ if it is a closed traverse, but if it is closed at this point, that clearly indicates that you have done some mistake in taking the measurements in any of the lines. You are not sure at what line. Okay, so when you're doing a survey for large area, you can't give an assurance that there is no impact of magnetic effect, or there's no impact of existence of features which will affect the performance of the magnetic needle in the compass. Here there may not be any magnetic effect. The magnet in the compass or the needle in the compass will give you accurate reading. But when you might have shifted to this place, you're not sure. There may be an effect of magnetic effect or there may not be an effect. So you are not sure whether the values taken at this point is wrong, or values taken at this point is wrong, or values taken at this point is wrong. Okay? But somehow you'll be getting some error. So that error can be rectified within the field itself. So that is the advantage of a closed traverse. But in the case of an open traverse, you can't determine or you can't give the assurance all the what is the accuracy of the values you have taken. I'm starting at this first point, then I'll move to second, then third, fourth, fifth. There is no relation between the first point and the last point. Okay? So I can't give you any assurance. But in the case of a closed traverse, I can give you an assurance depending on whether the last point and the first station point are coinciding or not. If at all they're not coinciding, by how much difference there is a mismatch, so that I can determine what is the error and then I can distribute that error to all the sides. Suppose here you got a 5 centimeter as the linear error. Okay, this line which is supposed to close at this point has closed at this point, and this gap between these 2 points is 5 centimeters. Okay, as I'm not aware at which point the error has occurred, I can distribute this 5 centimeter to all this. So 1, how many sides are there? 1, 2, 3, 4, 5. 5 sides are there. So 5 divided by 5 sides is nothing but 1 centimeter. So what I'll do, I'll move this second point by 1 centimeter. I'll move this third point by 1 centimeter, this fourth point by 1 centimeter, fifth point by 1 centimeter. Like that I can do if the error is very small. If the error is of considerable extent, then I can redistribute the error depending on the distances of other points from the starting point using a technique called as Bowditch rule. Okay, so using Bowditch rule, you can determine what is the error and you can distribute the error according to its distance from the starting point in a proportionate manner. Okay, so that is the advantage of doing a closed traverse. That is the reason why most of the times whenever we are doing the survey, we'll go for a closed traverse in order to ensure that the work done by us is accurate. Okay, but in an open traverse, it is not possible for us to uh, confirm the accuracy. But in one case, okay, you can also confirm whether the open traverse is correct or not if you are closing the work at a known point. Okay, similar to your leveling, you will be closing your day's work at a benchmark or at a temporary benchmark Okay. In the same way, if you're doing a compass traversing, if you're closing the day's work at a known point, then you can calculate whether the measurements taken by you in the field are correct or not. In that case also, a open traverse is considered to be a closed traverse because you're closing it with respect to the known values. Otherwise, an open traverse is not reliable completely. You can't give the assurance that whatever work you've done is perfectly right. Okay. So this is the principle of compass surveying. As you already said, it is a traversing. We are going to determine the linear lengths between the given station points, and we are going to determine what is the included angle. Here we will be determining what is the angle A, B, C, D, E. Okay. Once you know these linear distances and these angles, how do you determine the areas? Hmm? Once you know the linear distances and angles, how do you determine the areas? Please respond. No answers?
Sir, one second, repeat the question, sir.
Once you know the angles and linear distances, how you can determine the areas? Is it possible to determine the areas? See from the same figure, how to calculate the area? Hmm? You people should tell this answer. You have already completed diploma.
Sir, dividing a number of triangles, sir.
Dividing it to a number of triangles, and even you can use your sine rules, right? You know the angle, you know the opposite side.
Yes, sir.
So using those techniques, you can determine the areas. But preferably, we will be dividing this area into set of triangles. From here to here, you can divide. You can bisect this angle. So this will become a triangle, this side, and this side. You know this angle. You doesn't know what is this distance. You can determine this distance, right? Sine angle, sine A divided by this is equal to sine B divided by this, like that. Okay. So you can divide this into a set of triangles and you can determine the angles, or you can divide it into a set of trapezoids or quadrilateral. Then also you can determine the angles. Okay. The measurement quantity or the amount of work involved in measuring the values in the field will get reduced, but the calculations will be more in the office. Okay. That is the advantage of this compass surveying. Measurement field measurements will reduce, but office work increases. But though office work can be automated, so that is a major advantage. Okay. So there are two types of compasses which you might have already known: the prismatic compass and the surveyor compass. Okay. You can see on the right side, it's a prismatic compass. You're having a circular ring in the circular box. In that circular box, you're also again having a circular ring, and you're having a needle attaching the both sides of the circular ring. This one, and there will be graduations on the circular ring from 0 to 360, but it will be engraved in a reverse fashion. Okay. రివర్స్ లో ప్రింట్ అయి ఉంటాయి. ఈ స్టీల్ రింగ్ కనిపిస్తుంది కదా, దీని మీద మీకు గ్రాడ్యుయేషన్ 0 to 360 degrees ఉంటుంది. అవన్నీ మీకు రివర్స్ లో ప్రింట్ అయి ఉంటాయి దాని మీద. ఓకే. సో ఇన్ ఆర్డర్ టు
Inverted.
ఇన్వర్టెడ్, yes. So in order to see the value in a erected fashion, there is a provision for prism at this point. Okay. This one is a prism. So you need to, there will be a mechanism for you here to move the prism up and down till you are able to see the value clearly through your naked eye. So once you adjust that, then what you will be doing is, this is a slit you are having. Okay. This one you can see, this is the slit in which a fine thread will be there. You will be rotating your, you will be establishing your compass at the required station, and whatever angle you want to determine the object, you'll be rotating your compass to that object and ensure that the fine thread available in this slit is bisecting the given object. Okay. At that point, you will be seeing through the prism what is the angle in this circular ring. Okay. That gives you the angle. But basically, all these are bearings. These are not the angles. Whatever measurements you are taking using a compass are by default are the bearings, they are not the angles. I'll tell you the difference later. Okay. So the main purpose of giving prism for a prismatic compass is to ensure that the values which are engraved in an inverted fashion in the prismatic compass are seen normally by your naked eye. Okay. So these are some instruments which you already know. The what is tripod, all those things. What is plumb bob? I guess you know what is a plumb bob.
Sir, to do centering, sir, it was used.
What is tripod?
To set up the instrument, it is required, sir.
Okay, you can see in the figure it's a three-legged item or three-legged instrument which is used to fix the instrument. Either compass or tripods are also used in your plane table. It is all they are also used in your leveling operations. The shapes and sizes of the tripods may vary, but the purpose of the tripod is to ensure that it is fixed or it is centered over the instrument station point in the field and the corresponding instrument is fixed to it so that you can see from a certain height. Okay, because you can't carry all instruments in your hand and see. Okay, so that is the purpose of tripod. So coming to this is the actual concept which you need to have a clear idea. What is a bearing and what is an angle? Is there any difference between a bearing and an angle?
Sir, the angle measured with a fixed reference, such as like a north and south, is said to be a bearing, sir. Without any reference, it's called angle, sir.
Without any reference, it's called angle. Any other definitions? Anyone else?
Angle is between any two lines, sir.
Angle is between any two lines. Yes, right answer. So bearing is already all. Bearing is nothing but it is the horizontal angle which it makes with a reference line or a meridian, depending, okay, whether it is a true meridian or a true north or a magnetic north. Okay, the bearing is nothing but the angular value between the given survey line with respect to the given north, whether it can be true north or magnetic north. Whereas an angle is the difference in the values of angle, difference in the values of direction between two lines which share a common point. Okay, bearing is with respect to true north or magnetic north. In this figure, you can see, or in this figure, you can see this is the north, this is the east direction. Okay, the line, the direction of this line east with respect to north, it is called as the bearing. If it is with respect to true north, it is called as the true bearing. If it is with respect to the magnetic north, it is called as the magnetic bearing. Okay, whereas angle is suppose this vertical line is true north. Okay, so this is bearing. Similarly, this can also be bearing. Okay, we are having two survey lines here. This is the first line survey line. This is the second survey line. The direction or the angle between this true north or magnetic north and this survey line, this is called as a bearing. Based on true north or magnetic north, it can be true bearing or magnetic bearing. Similarly, for this line also, the direction of this line with respect to this reference meridian is called as the bearing. But angle is this one. The difference in the direction of two survey lines sharing a common point is called as an angle. So this portion is called as angle. This portion is called as a bearing. So you need to be very clear. Whatever values you are going to measure in the field are by default bearings and by default magnetic bearings for plane surveying techniques. You are using a prismatic compass, so you will be taking the measurements with respect to the magnetic north. Okay, so all your bearings by default in your surveying, plane surveying, or magnetic bearings and magnetic north. Okay, so this is you need to keep it in mind. What is true bearing? What is magnetic bearing? Like that. So there are four types of bearings. True bearing. The true bearing of a line is a horizontal angle between the true meridian and the survey line. Okay. True bearing or true meridian or true north is fixed with respect to astronomical objects like stars in the sky, whose position doesn't change with respect to the position of the earth. So if you have fixed a true north at one place, it is going to be the same till the earth exists. Okay. Whereas a magnetic north changes from place to place, changes at the same place from time to time, depending on the rotation of the earth, depending on the magnetic storms, depending on the variations in the electric fields, depending on the day-to-day revolution of the earth. Also, there is a possibility of change in the magnetic north. So that is why whenever you are taking the bearings, magnetic bearings with respect to surveying works, you need to clearly mention a term called as magnetic declination on the plan which you are preparing on the map on the sheet of paper. So that when you are calculating after 10 years or 20 years, then you can determine what is the magnetic north again, what is the magnetic declination. Based on that, you can determine what is the actual area, correct area. Okay, because the area doesn't change, right? If today there is a land of 200 square yards, after 20 years also the area of the land should be 200 square yards only. But today you have done a survey, okay, using a compass survey, and you have plotted it on a map or a plan, okay, and you have not mentioned what is the magnetic north, what is the magnetic declination at that point, okay. And if you go after 20 years and if you try to find out what is the magnetic declination, definitely there will be variation, okay. So the points changes. So that is why whenever you're doing a survey using compass, it is mandatory for you to say what is the magnetic north, okay, what is the magnetic declination at that place, and at what date, what time you have taken those readings. All those should be mentioned on the plan which you are preparing, so that in future it can be useful. Okay, but if you are measuring the readings with respect to true north, then you need not mention anything because it is going to be the same forever. Okay. So magnetic bearing is the line of a line is the horizontal angle which the line makes with the magnetic north. And you have one more bearing called as grid bearing. The grid bearing of a line is the horizontal angle which the line makes with the grid meridian. These are all you have already studied, so I'm just leaving. Okay, arbitrary bearing. But let us try to understand what is how we are going to represent the bearings and how to calculate one bearing system from another bearing system. Okay. So there are two types of designation of bearings. One is whole circle bearing system and the second one is quadrantal bearing system. Sometimes you also refer the quadrantal bearing system as the reduced bearing system. Okay. In the whole circle bearing system, we have measure from 0 to 360 degrees, but in the quadrantal bearing system, we measure from 0 to 90. The maximum, the values in whole circle bearing here ranges from 0 to 360, but in quadrantal bearing, the minimum value is 90, the minimum value is 0, maximum value is 90. Okay, please keep that in mind. In the first quadrant, we are going to have 0 to 90 degrees. In the second quadrant, we are going to have 90 to 180. In the third quadrant, 180 to 270. And in the fourth quadrant, 270 to 360 degrees. So I'll cover this in detail, but let us see first the whole circle bearing system. You can see how the angles are given there, 0 to 360 in the clockwise direction. Okay. So whenever you're here, you can see in the left hand figure, you're having four survey lines, OA, OB, OC, and OD. Okay. And you're having north, south, east, west, the quadrants which are represented there. So the bearing of the line OA with respect to north. Okay. Here, in the first step, the bearing of the line OA with respect to north. Okay. It is whole circle bearing. Let us assume that it is alpha as per his given question, as per the given notation here. Let us assume that it is theta or alpha, whatever it may be. Okay. So the bearing of a line OB now. Where is the bearing of the line OB? So we are going to measure from this point to this point. Okay. We are going to measure from this point to this point. What is the angular deviation? So that is going to be your whole circle bearing of line OB and whole circle bearing of line OC. So again, I'm going to measure from this point to this point. Okay, that is with respect to north only, I'm going to measure all my values. So this is going to be my whole circle bearing of OC. Similarly, whole circle bearing of OD. Though line OD is nearer to this north direction, I am not supposed to measure from north to this in this direction. I need to measure it in the clockwise direction only. So my reading will be like this. This is my whole circle bearing of line OD. So in whole circle bearing, what you need to keep in mind is all the values or the measurements are taken with respect to north direction only in the clockwise direction. Okay. But when you come to registered bearing or quadrantal bearing, okay, the first letter will definitely has to start either with respect to north or with respect to south, and the end letter will be either east or west. But the main thing what you need to keep it in mind here is in this in the last case you can see OD. Okay, this line OD, when you are taking in the reduced bearing system, I will write north, then I'll measure what is this angle. Okay, and I'll write it as west. I'll measure this angle. Okay, in the whole circle bearing system, I'm measuring in the clockwise direction. But when it comes to quadrantal bearing, I'm not bothered about the direction. I'm bothered only what is the angular distance with from the north direction in wherever it is nearer. Okay, instead of measuring from here to here, I'm measuring from here to here. Similarly, in the south direction also you can see. Okay, I'm going to, in the second quadrant also you can see I'm going to measure what is the direction or what is the angle of this line OB from south. So in this value. Similarly, here in the third quadrant I'm going to measure again from south. In the first quadrant I'm going to measure from the north. Okay, so you need to keep one point in mind. In the first quadrant and third quadrant, you are going to measure the angle or the bearing of the line, okay, with respect to north direction only. In the second and third quadrants, you are going to measure the bearing from with respect to south only. Okay, so whenever there is a line surveying in first quadrant, so it gives north theta east. In the second quadrant, south theta east. In the third quadrant, south theta west. In the fourth quadrant, north theta west. Okay, you please keep this notation in mind. Okay, so this is what I explained here. So the angle OA, the bearing of line OA is 70 degrees. Okay, so the whole circle bearing will be 70, whereas the reduced bearing or the quadrantal bearing will be north 70 degrees east, because line OA is in the quadrant northeast. Similarly, second quadrant line OB, it is at an angle of 35 degrees from south. So the quadrantal bearing is south 35 degrees east. What will be the whole circle bearing for this case? Whole circle bearing is with respect to north. From here to here, what is the angle? This portion.
155.
How do I get this portion? From here to here, it is
180 minus 35, sir.
from north to south, it is 180, right? You all accept it is semicircle. Okay. From north to south, it is 180. From south to this line, it is 35. So if I want this portion, 180 minus 35. So it is 145. Antena? 145 or 155? 180 minus 35.
145, sir.
So the
145.
whole circle bearing of OB is 145 degrees. Now come to this point, third quadrant, line OC. The quadrantal bearing is south 55 degrees west, because it is in the southwest quadrant, and the angle between this south line and the C line is 55 degrees. So what is its whole circle bearing? Whole circle bearing means again from this
180
point to
plus 55,
this
sir.
point. What is this angle?
235, sir.
235, sir.
So okay, from here to here it is 180 plus 55. So 235. Similarly, tell me what is the value for last one, OD? The quadrantal bearing of OD is from north to D, it is 30 degrees. So north 30 degrees west is the quadrantal bearing. So what will be its whole circle bearing?
330.
330, sir.
So this is the value I want. So whole circle is 360 minus simply 30. If I do, I will be getting the whole circle bearing as 330 degrees. Okay. So you can convert, if in whatever mechanism the question is given, okay, you can convert into another format. If values are given in whole circle bearing, you can convert them into reduced bearing. If they are given in reduced bearing, you can convert into whole circle bearing. But the prime thing what you need to keep it in mind is the number of quadrants and the ranges of quadrants. Keep it in mind, you have only four quadrants: northeast, southeast, southwest, northwest, and the quadrant values ranges from 0 to 90, 90 to 180, 180 to 270, 270 to 360. ఈ ఫోర్ వాల్యూస్ మీరు కనుక గుర్తుపెట్టుకున్నట్టయితే you can simply play with the problems. Okay, so this is the sum table which you can use for converting from one system to other system. But my sincere suggestion, instead of remembering these equations, you remember this concept. Four quadrants draw చేసుకోండి. మీకు బేరింగ్ వాల్యూ ఎంత అన్నది ఇస్తాడు, ఇచ్చిన దాన్ని బట్టి మీరు డయాగ్రామ్ డ్రా చేయండి. డయాగ్రామ్ డ్రా చేసిన తర్వాత యూ కెన్ డూ సింపుల్ అడిషన్ ఆర్ సబ్ట్రాక్షన్. 180 ప్లస్ ఉంటుంది లేదా 180 మైనస్ ఉంటుంది. ఓకే,
Yes, sir.
but anyway, keep this table also in mind. So if the whole circle bearing is from 0 to 90 degrees, okay, reduced bearing will be the same, but the quadrant you need to mention it as northeast. So suppose if the whole circle bearing is 70 degrees, so how do we represent its quadrantal bearing? North 70 degrees east. Okay, if the whole circle bearing is from 90 to 180, the reduced bearing is given by 180 minus whole circle bearing, and the quadrant is southeast. Similarly, 180 to 270, WCB minus 180, southwest, 270 to 360 if it is there, then adjacent bearing is 360 minus whole circle bearing, quadrant is northwest. Okay. Similarly, when the values are given in the reduced bearing system, if you want to get into the whole circle bearing system, if the survey line is in the northeast quadrant, the numerical value of reduced bearing is equal to quadrant whole circle bearing. Okay, just remove the northeast. Okay, whatever numerical value is there in the reduced bearing, the same thing you can represent as the whole circle bearing. If the reduced bearing is in the southeast quadrant, then you need to subtract that from 180 in order to get your whole circle bearing. Here what we did now. Okay, in the second quadrant, you have subtracted from 180 35, so you got 145. Okay, similarly, if it is in the southwest quadrant, you need to add 180 to the reduced bearing. Here you are having reduced bearing 55. Here, for that I have added 180 in order to get the whole circle bearing. Similarly, if it is in northwest, subtract the reduced bearing from 360 degrees, you will be getting the whole circle bearing value. Okay, just try to solve the things using a diagram. If not, if you find it difficult, please remember these values. Okay, so what do we mean by forebearing and back bearing? These are very basic things which are required for doing our surveying. Okay, the bearing of a line measured in the forward direction of survey line is called as a forebearing. Okay, if I am doing a surveying from A to B, I have started my survey at A and I am moving towards the B direction. The bearing which you are taking in the direction of A and B with respect to north is called as a forebearing. Okay, and the bearing of the line measured in the direction opposite to the direction of progress of survey is called as a back bearing. So when I am moving from A to B, okay, the bearing which I am taking with respect to north is called as the forebearing. Similarly, the bearing BA which I am taking with respect to north only, but in the opposite direction of the survey, నేను ఇటు నుంచి ఇటు వెళ్తున్నా, బట్ ఇక్కడ మెజర్మెంట్ నేను ఎట్లా తీసుకుంటున్నాను, ఇక్కడ నార్త్ డైరెక్షన్ తీసుకుంటున్నా, ఈ డైరెక్షన్ లో తీసుకుంటున్నాను. సో ఇట్ విల్ బి అ బ్యాక్ బేరింగ్. Okay, so the bearing whichever is taken in the direction of the survey line is called as the forebearing. The bearing whichever is taken in the backward direction is called as the back bearing, and these two are interrelated. Forebearing and back bearing differ by an angle of 180 degrees. How? Can any one of you tell me? The forebearing plus or minus back bearing is equal to 180. How do you prove that? In the figure you can see this angle is theta.
Alternate
This
angles are same, sir.
Yeah,
Sir,
this angle
based
is
on the
theta.
alternate angles.
Okay, this is the angle theta, right? So what will be this angle at this position? What will be this angle? సేమ్ ఉంటుందా, theta ఉంటుందా, వేరే ఉంటుందా?
Same, sir.
Because this is a straight line, the angle will be the same with respect to the perpendicular. Okay, You can see in this figure, up to this point, this is okay theta. Then what about this portion? It is 180 ఉంటుంది కదా? Because it is semicircle, right? It is a straight line. So what will be this angle? It is 180. Okay. So if a forebearing is given to you, then if you want to calculate the back bearing here, what you are doing? You are adding 180 degrees to the given forebearing. Okay. So in that way, you need to calculate the forebearing and back bearing. If it is given, forebearing is equal to back bearing plus or minus 180. Okay. You need to apply, you need to add 180 when the given forebearing is less than 180, and you need to apply minus sign when the given forebearing is greater than 180. Okay. So this is for whole circle bearing system. But when you are using the quadrantal bearing system, simply just change the notation. The numerical values remains the same, only the direction changes. If the, for example, if you see here, the forebearing of a given line AB is 60 degrees north, 60 degrees east, then its back bearing is south 60 degrees west. How can we prove that? The forebearing is given as north 60 degrees east. Which quadrant? North 60 degrees east. ఏ quadrant లో వస్తుంది?
First quadrant.
First quadrant, sir.
So this is AB. Okay. So this is A. And this point is B. Okay, the value which she has given is, this angle is 60 degrees she has given. Okay. So what will be its back bearing? Okay. As per this slide is saying that it is south 60 degrees west. Okay. So what is back bearing? So simply draw a quadrant here also. Okay. So for this A point, this is north, this is east, right? This is north. This is east. Kada? For this point, for P point, this is east. This is south. This is west. Do you all accept?
Yes, sir.
Okay. So what is the back bearing of AB now? From where I need to measure?
From south.
This is north, right? For B point, this is north. Okay. By the definition of bearing, okay, from here to here, right? Because the bearing is measured with respect to north direction. Okay. Or with respect to south direction. So now what will be this value now? Why numerical value?
240 degrees.
Southwest, sir.
Why numerical value is remaining same? If I extend this line, so this angle is also 60 now. E portion. Same concept. ఇందాక మనం ఏదైతే అప్లై చేసాము. This angle is 60 కదా, ఎందుకంటే కింద 60 ఉంది కదా. Same straight line. ఇక్కడ ఈ యాంగిల్ 60 ఉన్నప్పుడు, ఓకే, ఈ యాంగిల్ కూడా 60 అవుతుంది కదా. అవునా?
Yes, sir.
ఈ యాంగిల్ 60 అయినప్పుడు ఈ యాంగిల్ ఎంత అవుతుంది?
60, sir.
This angle is also 60 because opposite angles are equal కదా. అవునా?
Yes, sir.
Okay. Now you consider this line. Where is this line? This line is in the quadrant southwest, right? ఈ లైన్ మీరు తీసుకుంటే ఇక్కడ ఈ B పాయింట్ దగ్గర ఎక్కడికి వస్తుంది? ఇది సౌత్ వెస్ట్ క్వాడ్రంట్ లోకి వస్తుంది. Okay. So that is why here you can see the back bearing of line AB is south 60 degrees west. 60 degrees ఎందుకు వచ్చింది? ఈ 60 degrees ప్లస్ ఇది 60 అవుతుంది. ఇది 60 అన్నప్పుడు ఇది ఆపోజిట్ యాంగిల్ కాబట్టి ఇది 60 అవుతుంది. So the numerical value is remaining the same. Only the directions are changing from north to south and east to west. That is the logic behind this forebearing and back bearing if the given system is quadrantal bearing. Okay. If the given system is whole circle bearing, then in order to determine the back bearing or forebearing, okay, you need to add or subtract 180. But if the given system is quadrantal bearing, you need not bother about the numerical value. Okay, simply change the directions. North unte south cheyandi, east unte west cheyandi, south unte north cheyandi, west unte east cheyandi, and retain the numerical value as it is. Okay, further this is the explanation. Okay, so ఇక్కడ నుంచి లైన్ నీకు నార్త్ ఈస్ట్ డైరెక్ట్ సౌత్ లో నార్త్ ఈస్ట్ క్వాడ్రంట్ లో ఉంది, బట్ వెన్ యూ గో టు ద పాయింట్ బి ఇట్ ఈస్ దిస్ లైన్ ఈస్ ఇన్ ద సౌత్ వెస్ట్ క్వాడ్రంట్. సో బ్యాక్ బేరింగ్ ప్రకారం మనం బ్యాక్ బేరింగ్ డెఫినేషన్ ప్రకారం ఏంటి, ఇట్ ఈస్ ద బేరింగ్ ఆఫ్ ద లైన్ టేకెన్ ఇన్ ద reverse direction of survey. I'm moving from A to B. A to B is my direction of survey. But I want what is the bearing of B to A. Okay. For that, I'll be getting this thing. Okay. We'll try to solve some problems, then you'll be able to better understand. Okay. Take down this value. First one. The first question. Convert the following whole circle bearing into reduced bearing. So first try to draw the diagram. Till you get perfect, I sincerely suggest you to draw the diagrams. So this is my quadrant, north, east, west, south. This is north. Then this is south. This is east. This is west. Okay. So convert the whole circle bearing into reduced bearing. Where does 49 degrees come?
First
Which quadrant?
quadrant, sir.
Northeast quadrant.
So 49 degrees under 0 to 90 madhya untundi kabatti assume that this is the whole circle bearing of 49 degrees. So what will be its corresponding reduced bearing?
Northeast 49 degrees, sir.
North 49 east. You need to mention as north 49 east. Okay. So next is 240 degrees. So which quadrant 240 comes?
Third quadrant, sir.
Third quadrant.
So third quadrant. So simply draw a line somewhere here. Okay. So 240 అంటే ఇక్కడ నుంచి ఇదంతా 240 degrees, right? అంతే కదా, హోల్ సర్కిల్ బేరింగ్ అంటే విత్ రెస్పెక్ట్ టు నార్త్. ఇక్కడ నుంచి ఇక్కడ వరకు 240. బట్ క్వాడ్రంటల్ బేరింగ్ లో నాకు ఏం కావాలి? వాట్ ఈస్ ద యాంగిల్ బిట్వీన్ హియర్ టు హియర్?
60, sir.
South 60 degrees west, sir.
సో సౌత్
60.
60 degrees west.
60 degrees west. Remaining people, please tell me how you got 60?
240 minus 180 degrees, sir.
మిగతా వాళ్ళు చెప్పండి అమ్మా, ఒక్కళ్ళే కాదు.
Sir, 240 minus 180.
అంతే కదా, ఇక్కడ నుంచి ఇదంతా 240 degrees ఈ లైన్. ఓకే, నాకు కావాల్సింది ఇదే లైన్ కాబట్టి ఇక్కడ స్ట్రేట్ లైన్ 180 degrees కాబట్టి 240 లైన్ నుంచి 180 తీసేస్తే నాకు 60 వస్తుంది. ఓకే, సో నెక్స్ట్ ఈజ్ 133 degrees. 133 ఏ క్వాడ్రంట్ లో వస్తుంది?
Second quadrant, sir.
Second quadrant.
Second quadrant. I am removing this. So this whole angle is 133 degrees. So what is the quadrantal bearing now? What is the notation first?
South.
East 47 degrees, sir.
South
South
47 degrees.
47 degrees.
47
east,
degrees.
sir.
East. ఎందుకంటే 180 మైనస్ 133 చేస్తే ఎంత వస్తుంది? 47 degrees వస్తుంది. సో లాస్ట్ వన్ ఈస్ 335. ఏ క్వాడ్రంట్?
Fourth quadrant.
Fourth quadrant.
ఫోర్త్ క్వాడ్రంట్. సో
Cassie.
ఇక్కడ నుంచి ఇక్కడ వరకు ఇట్ ఈస్ 335 degrees. So what is this value now?
North 25
degrees
west.
west, sir.
So north 25 degrees.
North
West.
35 degrees
Right,
west.
25 yeah.
25 sir.
25 degrees west. Okay. అర్థమైందా?
ఎస్ సార్ అర్థమైంది.
So I'll not explain now. I'll just give you one more example. Please try to solve it. Huh? Yeah, this is the question. Convert the following whole circle bearing into adjacent bearing. 190 degrees, 260 degrees, 315 degrees. Please try. Hmm? Yeah, tell me the. First, let me see your faces once. All of you, please, on your video. I didn't see you people till now. I was seeing the regulars, but have you seen me? చూసారా?
No, sir.
Yes, sir.
ఉన్నారో వచ్చారుగా ముగ్గురు కోతులు కాలేజ్కి. ఈయనేంటి ఈ అబ్బాయి బయట కూర్చొని వింటున్నట్టున్నాడు? రూల్ నెంబర్ 302 ఎక్కడ ఉన్నావు నాయన?
బయట సార్ లోపల నెట్ రా సార్ పల్లెటూరు.
Okay, remaining people, please show your faces once. Okay. So tell me the answers. The whole circle bearing is 190. What is reduced bearing now?
South 10 degrees west sir.
I need at least 4 to 5 people to respond with answers.
That's south 10 degrees west, sir.
2 more. ఇంకెవరైనా చెప్పండి ఆన్సర్ నాకు.
సౌత్ 10 degrees west.
Okay.
South 10 degrees west.
Okay, 1 second. Rule number 308. వీడియో ఆన్ చేసుకొని వెళ్ళిపోయాడా?
సార్
Tell me the answer for 260 degrees. If the whole circle bearing is 260, what is its quadrantal bearing? తొందరగా. Three 318. 310.
Sir.
ఓ నువ్వే కదా ఇందాక నుంచి నువ్వేగా చెప్తుంది.
Yes.
305.
Sir, south 80 degrees west, sir.
South?
South 80 degrees west.
South 80 degrees west. The first one is south 10 degrees west. Second is south 80 degrees west. What is third one for 315 degrees?
North 45 degrees west.
North 45 degrees west.
45 degrees west sir.
Okay, good. Now let us do a different problem. So please take down this problem. Now here what he has given you the whole circle. He has given you the reduced bearings. Okay. He has given you the reduced bearings. Please first draw the diagram. Is given you the reduced bearing. In the first problem, మనం whole circle bearing is the reduced bearing convert చేసాము. ఇప్పుడు whole reduced bearing ఇచ్చాడు. Now we need to determine what is whole circle bearing. First, draw the quadrant, draw the lines. Once you are done, please let me know. అయిందా?
Yes, sir.
So what are the answers?
65 degrees, sir. First one.
55 degrees
65
first
degrees,
one.
sir, first one.
Okay.
Second one,
136 degrees 45 minutes. Second one, sir.
130.
136 degrees 45 minutes.
45 minutes.
Okay. Third one.
232 degrees 30 seconds.
235 degrees 30 minutes.
232 degrees
30 seconds.
35, sir.
to
235 degrees 30 minutes.
235 ఎట్లా వస్తుందమ్మా?
32, sir.
It is 232
degrees.
180 plus 52 degrees 30 minutes కదా. 180 plus 52 అంటే 232 కదా. 232 30.
Yes, sir.
Fourth one.
327 degrees 18 minutes.
327 degrees 18 minutes, sir.
37 degrees 18 minutes. Okay. So shall I move to next one? I hope it's clear now.
Yes, sir.
Sir.
Whole circle bearing is a quadrantal bearing low. Quadrantal bearing is the whole circle bearing low. But one thing you keep it in mind, whenever the problem is given for you in quadrantal bearing system, first please convert it to whole circle bearing system. Calculations easy అవుతాయి. Okay. whole circle bearing లో కన్వర్ట్ చేసిన తర్వాత మీరు ప్రాబ్లం అంతా సాల్వ్ చేసిన తర్వాత మళ్ళీ దాన్ని క్వాడ్రంటల్ బేరింగ్ లో కన్వర్ట్ చేయండి ఫైనల్ గా. ఓకే.
Okay, sir.
సో నెక్స్ట్ వన్ we are having another problem. What is forebearing and back bearing చెప్పాను కదా ఆల్రెడీ ఇప్పుడు. So let us solve one more. The following are forebearings were observed for lines AB, BC, CD, DE, EF and FG respectively. Determine their back bearings. Okay. So what is the equation we need to use? Forebearing is equal to back bearing
Plus or minus
plus or
180.
minus 180. Okay. If less than 180, add 180. If more than 180, subtract 180. So what is given here now? Forebearing of line AB is 148. What is its back bearing now?
325 degrees, sir.
So back bearing of AB is equal to 148 plus 180. How much?
328, sir.
328. Next, back bearing of BC is equal to forebearing of BC at the 65. So what I need to do? Add or subtract?
Add, sir.
Add 180. It is 245.
245 degrees.
Okay, back bearing of CD is equal to 285 only. What I need to do?
Subtract, sir.
Subtract 180. What is the value?
105 degree.
5, sir.
Sir.
105.
Back bearing of
105.
DE is 215 minus 180.
35 degrees, sir.
45 degrees, sir.
35. Now see the twist. Not 36 degrees west.
36 है sir.
South 36 east,
South
sir.
west है sir.
Southwest. Okay, convert that into whole circle bearing and tell me what is the value.
144, sir.
Convert that north 36 degrees west to whole circle bearing and tell me what is back
126.
bearing.
126, sir. 126.
126 are wrong.
140.
Huh?
326.
24 sir.
324, sir.
Back bearing of EF is equal to, actually it is south 36 degrees east. Okay? అంతే కదా? But if you convert it into whole circle bearing, what is the value?
144, sir.
What is the value? Please tell me, all of you.
144 degree.
144.
Okay, next one, back bearing of
Yes, sir.
FG is equal to north 40 degrees east. So if you convert it to whole circle bearing, what will be the value?
320.
220. 220.
220. Okay.
220.
So this is how,
220 sir.
okay. This is how you need to calculate. Simple calculation. If four bearing is given, if you want to determine what is the back bearing, plus or minus 180, depending on if it is less than 180, add 180. If it is more than 180, subtract 180. Okay. If he has given back bearing, then you can also calculate what is the four bearing using the same equation. Okay.
The last one.
The same, this is one more problem. Will you solve it or shall I leave this? Try to solve this problem once and tell me the answers. The four bearings are given here. Tell me the back bearings. Tell me the answers quick.
Sir, first one 130 degrees, 30 minutes, sir.
First one.
130 degrees 30 minutes sir.
30 minutes.
Okay. Second one.
325 degrees 15 minutes.
15 minutes.
Okay. Third one.
30 degrees.
Degrees
30
30
minutes.
minutes.
30
Fourth
degrees.
one.
240 degrees.
240 degrees, 45 minutes.
45 minutes.
Okay. So I'll stop today. Tomorrow we'll see how to calculate the angles from these bearings.
Okay, sir.
Right. Tomorrow also we'll start at 6:30. Okay. Thank you. Bye for the day.
Attendance, sir.